So we went ahead and talked about Bohr's model of the atom a little bit, and that's a little review from integrated science. So what we're going to be talking about today is the quantum model of the atom. Okay. And so we're going to be talking about electrons and their probability of where we can find them and why we talk about why it's a probability and not an actual location of where we know they're at. Okay. So just a review from what you guys learned in your last note. What is a quantum? Well, a quantum is just energy. Okay, so it's just energy that's added to an electron. Okay, and so we say a quantum leap is when an electron gains energy from a photon, it'll jump up. When it loses energy, it jumps down. Okay, so what shell has more energy level? Well, think about it. If I have to gain energy, okay, to jump up in a level, a higher energy level is going to have more energy than a lower energy level. So basically, the way you can tell which one has more energy is just look to see which energy level is bigger. Well, energy level 6 is going to be further out from the nucleus. Okay, so you have the nucleus, you're going to have energy level 1, 2, 3, 4, 5, 6, and then up to 7. Okay, so the further out the energy level, okay, or the bigger the energy level, the more energy the energy level has. So N6 is going to be your energy level. How many electrons or how an electron moves to a higher energy level? Well, a little review. The only way an energy or an electron can move energy levels is it has to absorb a photon or it has to absorb energy. Okay, so it absorbs energy. In this case, it's a photon. Ooh, spelled that wrong. Okay, what happens when an electron emits a photon? What do we see? Well, if you guys remember when we were discussing on Bohr's model, when a photon is released, okay, we actually see it as a color. And depending on how far it drops, okay, it tells us the wavelength. And so the bigger the drop, the bigger the wavelength, the more energy it gave off. Therefore, it's probably going to be a purple, a blue, or a green. Whereas if it's only dropping from energy level 3 to 2, it may only give off a red. Okay. And so what do we see is we see color. Okay. Now, in the development of the quantum model, what we know is electrons actually act as particles and waves. Okay. And so we have uncertainty in trying to locate an electron because electrons are only detected by their interaction with a photon or a light particle because we can actually see it when it interacts with an electron. But the photon will knock the electron off course. So if a photon hits the electron is going to go this way, okay, and the photon's going to go this way. And so we can only see the interaction once they hit each other. So Heisenberg's uncertainty principle says it's impossible to determine simultaneously both the position and velocity of electron. So this is going to be an important term for you guys to write down. So the reason being, well, think about it. Can we see electrons? No. And they're moving way too fast. So Heisenberg said it's impossible to determine exactly where an electron's going to be at any given time. Okay? Doesn't mean they're not there, just means we can't predict. So, the quantum theory tells us where electrons are probably going to be. And these probabilities are detected as electron density clouds. So the dense areas is the higher probability. Okay. So if we look, the nucleus is in the center. Okay. And then we see these dark clouds, and you can notice there's rings. So we have a ring here. And we also have a ring here. Well, these are shown as energy levels. Okay, so this would be energy level 1, and then the outside ring would be energy level 2. And so if we continued, okay, we would probably see, more dense clouds as the further we get out. And so this is why we know electrons are traveling in orbits, okay? And so if you notice, the closer we are to the nucleus, the higher probability of seeing an electron. And the reason being is it's a darker shade, meaning the interaction between a photon and an electron is at its highest. Okay. And so you can see there's a space in between. So there's a less likelihood of electrons being in that area. Doesn't mean they're not there. The probability of them being there is very slim. Okay, and so the reason we see them in energy levels is because electrons have certain energy levels. Okay, and those photons give them energy. So moving on. So the quantum theory is a mathematically described wave property of electrons. Okay, and so you just need to know this was developed by Schrodinger. Okay, electrons still can have fixed amounts of energy, and they do not follow an exact path. So where in Bohr's model, we thought that they just traveled in circles, okay, kind of like planets around the sun. What we actually see electrons do is they act in a wave type, okay? And so they kind of go in and out. So that is what Schrodinger was saying. And then the fixed amount of energy would tell us whether it was an energy level 2, energy level 1, or energy level 3, even 4, 5, and 6. So, ways to describe an electron and its probable location. So we put it into 4 things. Its energy level, so the distance from the nucleus. So we've talked about N1, N2. Okay, so you'll have N equals 1, N equals 2, N equals 3, N equals 4, N equals 5, N equals 6, N equals 7. Okay? So obviously, N1 is going to be closest to the nucleus, N7 is going to be furthest from the nucleus. Okay? The second thing we talk about, and it's what you guys are going to be learning today, are the shapes of an electron cloud. And so the sublevels that we talk about are S, P, D, and F. Okay, so we'll be talking about the shapes with these sublevels, but you have the S sublevel, you have the P sublevel, you have the D sublevel, and you have the F sublevel. Okay, so when we talk about each sublevel, we talk about atomic orbitals. So there's regions of space in the energy level and the sublevel where an electron probably is. And so each one of these has a certain regions of space. Okay, so when we talk about the S sublevel, it has 1 orbital. When we talk about the D sublevel, it has 3 orbitals. If we talk about the I skipped P. P is 3. D is 5 sublevels, or I should say orbitals. And then I don't have space, so I'm going to write it over here. F has 7 orbitals. Okay. Now, they also take into account the spin. So it's either an up spin or a down spin. So electrons are actually spinning, kind of like our Earth is spinning around the sun, so is electrons. And so they're either going to be spinning clockwise or counterclockwise. All right, and we'll be talking about that as we draw out electron configurations. So what does the energy levels mean? Well, the energy level is just the distance from the nucleus. The further from the nucleus, the more energy it can have. So if we look, energy level 1, 2, 3, and 4, if I were to ask you which one has more energy level, your answer would be energy level 4, because it's furthest from the nucleus. Okay? Now, they can have unlimited number of energy levels, but there's only one problem. We only have enough elements to fill 7 energy levels. Okay? And so while theoretically we could have 8, 9, 10, it's not plausible. All right. And so there's just no atoms with electrons and more than 7 energy levels. All energy levels contain at least 1 sublevel or cloud shape. And we'll be talking about these sublevels here in a second. Okay, so your sublevels describe the shape of an electron density cloud within that level. Okay, so there's types of sublevels. You have an S, P, D, and F. We just talked about those. And the sublevels each have different number of atomic orbitals. And so if you guys are confused, I went and told you how many orbitals are in each sublevel. Sublevel being the letter, orbitals being the amount of regions of space in that sublevel. Okay, and so an orbital can hold 2 electrons. Okay, and we're going to be talking about this, and I have a worksheet that you guys are going to do, and I'm also going to post a video of me helping you guys with the worksheet to kind of see where you're drawing out information. But make sure you guys are writing these notes down. I promise you, you're going to need these. Okay, so types of sublevels. So when we talk about an S sublevel, we say it's a sphere, but just think of a sphere, but anywhere in that sphere, an electron can be held. Okay, and so this is one orbital here. Okay, so there's actually 2 electrons that can be held within this orbit. Okay, so somewhere in this sphere, there's 2 electrons moving in a wave-like manner. Okay, it is the lowest energy. When we talk about the P sublevel, it's a dumbbell shape. There are 3 orbitals. So if you guys actually look, I've actually put 2 photos up here. One is the yellow, one is the blue. So if you notice, the yellow has all 3 of these orbitals together. So one orbital is right here. Okay, so you have electrons. You'll have an electron in this orbit. You'll have an electron in this orbit. You'll have an electron in this orbit, orbit, and orbit. Okay, so it can hold up to 6 electrons, and I just placed those 6. Now notice these electrons, they're going to travel in a wave-like property. Okay, and so they're orbiting kind of in a 8 shape. Okay, and so when we put these together, you can see you have one orbit here. Okay, that holds 2 electrons. You have one orbit here that holds 2 electrons. And then you also have an orbit over here that holds 2 electrons. Okay, so the P sublevel is just saying a region of space in which electrons are going to move. Okay, and so a region in which you are probably going to find the electrons. And then it's just saying the shape because of how they're moving based on their wave-like property. Okay, so what you need to remember is S is a sphere shape. It has one orbital, and this orbital can hold 2 electrons. Okay, and so these electrons are moving around. And this second electron you can't really see, so I'm going to just put a different color. And then the P sublevel, it's a dumbbell shape, which you guys can see. It kind of looks like a dumbbell that you lift at the gym. It has 3 orbitals, which we see here. They're on different axes. And then it can hold 6 electrons. And I kind of show you an electron being held in each of those orbits. So D sublevel. Okay, and so all you need to remember for D sublevel is it does start getting trickier because as the further we get out, the more space we have for electrons to move. Okay, and so with that being said, if electrons can move more, there's going to be more areas of space. And so you can see we have all of these different types of orbits. Okay, and so we have 5 orbitals. And so the electron, you'll have an electron in each one of these in their own orbits. And so if you count, there's going to be 10 electrons that can be held in each one of these 5 orbitals. Okay? And so kind of like how we joined them in the P sublevel, well, it's kind of hard to see. And so when you join all of these together, okay, just know the electrons start moving in regions of space. Okay, so the big thing that I want you to remember is D sublevel has 5 orbitals, which you can see. Okay, this is 1, 2, 3, 4, and 5. Okay, so the last sublevel we're going to talk about is the F sublevel, and it has 7 orbitals. It can hold 18 electrons, 2 in each orbital, and you guys can see that they just get crazy. Okay, and so as we get further out, we have more space, so we can have more orbits or orbitals that can hold more electrons. All right, and so we have 7 here: 1, 2, 3, 4, 5, 6, 7. Okay, and so you can see the different shades of pink. So there'll be an electron in the dark pink, light pink, pink. Okay, and so with 7 orbitals, each holding 2 electrons, I can hold 14 electrons. Okay, now there could be more sublevels. We just don't have enough energy levels to hold them. Okay, or we don't, not energy levels. We don't have enough electrons to have more sublevels. Okay, so this is the highest energy because they're going to be in the furthest part of the atom. All right, and so they're going to be in higher energy levels. Okay, now atomic orbitals. Just remember, N is 1 sublevel. Okay, it has an S sublevel, so I need you to write these down, and I'm actually going to show you how to see this on a periodic table. Okay, energy level 2 has 2 sublevels. It has S and P. Energy level 3 has 3 sublevels, S, P, and D. Okay, and energy level 4 has 4 sublevels, which is S, P, D, and F. Okay, so just remember each sublevel has the orbital. So energy level 1 has 1 orbital. Energy level 2 has 4 orbitals because S has 1 orbital, P has 3. Energy level 3 has 9 orbitals. And then energy level 4 has 9 plus 7, which is 16 orbitals. Okay. So when we talk about spin, just once again, the spin is just showing magnetic properties of an electron. Okay, so for every counterclockwise, we're going to have a clockwise spin. All right, so just understand that's all the spin is telling me. It's accounting for magnetic properties. Okay, and if you want to draw this real quick, go ahead. So there are rules with electron configurations, and we're going to be talking about this. So this may not make sense right now. Okay, but I'm going to show you guys how to use your periodic tables. Okay, so if you guys notice on the periodic table, okay, we have the sublevels in here. All right, and so your energy levels are shown by your period numbers. So period 1 is energy level 1, period 2 is energy level 2, period 3 is energy level 3, period 4 is energy level 4, 5, 6, and 7. Okay, and now you see the F subblock. So what I want you guys to go ahead and look is the F subblock actually fits between the S and the D. So this is what your periodic table is supposed to look like. And so tomorrow, okay, which it should be your Friday, you guys are going to be using these subblocks. Okay, and so I'm going to give you guys the link to where you can find these. If you guys want to print out a periodic table and cut one and color it so you guys can have one, that would probably be best. Okay, otherwise you're going to be using these. All right. So off-ball principle, electrons occupy the lowest energy level orbital first, okay, or closest to the nucleus. So the off-ball diagram is going to fill 1s, okay, and remember, 2 electrons are going to fill each one of these electron configurations. Okay, so if I have 1 electron, 2 electrons, so remember we account for spin. Okay, each arrow represents 1 electron. Once I fill my 1s, okay, and so you guys have to think about this. Remember, S sublevels have 1 orbital, right? P sublevels, and I'm going to go ahead and make this thinner. P sublevels have 3 orbitals. D sublevels have 5 orbitals. And so we show these orbitals with these lines. Okay, and so each line is just representing a region of space within that sublevel, and the sublevel being S, P, D, and F. Okay, and then if I had F, it would eventually be 7 sublevels. Okay, and so I'm going to be teaching you guys how to use this, but essentially we show electrons by these arrows. So 1 electron, 2 electron. Once I fill my 1s, I'm going to go to my 2s. 3 electrons, 4 electrons, 5, 6. Now notice I'm going ahead and filling all ups before I fill any downs. Okay, and so I'm going to explain the rule to this. And you guys are going to be practicing this tomorrow. And it would go so on. So it'd be 1s, 2s, 2p, 3s, 4p, or 3p, 4s. And I'm even going to show you guys how to find this. So if I look at the subatomic level, if I look at the periodic table with the subblocks, I fill 1s. And so you'll notice that follows the notes that you guys just wrote. Then you go 2s. And so I'm going top to bottom, left to right. 2p. Then I drop down to the third energy level, 3s, 3p, 4s. Now, this is where it starts getting tricky. And on Friday, I'm going to explain why this is in our video chat. We get to 3d. Then we go to 4p. Then we go to 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5s, or 5f, 6d, 7p. So where we're getting this off-bar diagram that you're seeing is based on what I just showed you. And so I'm going to show you guys again on Friday to kind of reiterate it. But just understand this off-bar diagram isn't just made up. Okay, it's based on energy levels, orbitals, and how many electrons can be held in those orbitals. Okay, and so if you guys want to, here's the orbitals that you have. Okay, if you want to know, just always put one line after every s, put 3 lines after every p, because p's have 5 orbitals. After every, or 3 orbitals, sorry. D has 5 orbitals. So after every D, you can put 5 orbitals or 5 lines. And after every F, we could put 7. Okay, so if you want to, here is the off-ball diagram in order for you guys. And so I'm going to come back and explain this, and I'm going to be using this. But so for every S, there's 1 orbital. Every P, there's 3. So this S would have 1. This would have 3. This would have 1, and so on. Okay, so here's the order of the off-ball diagram. And if you want to use the periodic table, the order will follow what I just showed you on this. Okay, so once again, this is just another way to show the off-ball diagram. We just go 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. This is just following the off-ball diagram. So how many sublevels are in energy level 2? Okay, well, anything that has a 2 in front of it is energy level 2. So I have 2 sublevels. I have an S sublevel and a P sublevel. And if I come to the periodic table, in my second energy level, I have 2s and 2p. So it follows I have 2 sublevels. Okay, and so if I were to be asked, how many orbitals do I have in that? I would actually have 4, because remember, S has 1 orbital and P has 3 orbitals. Okay, so how many sublevels are possible in energy level 6? Okay, well, technically we can go forever, but we really only have 2 that are going to be used. But realistically, we could have 6 based on what this is being shown, but we're not going to get into that. Realistically, we're only going to be possibly using 2, 6S and 6P, because we don't have enough to fill 6D, 6F, 6G, and 6H. And if you look on the periodic table, we don't have anything else. We only have a 6S, a 6D, and a 6P. Okay. So Pauli Exclusion Act says no electrons can have the same 4 quantum numbers. Okay, so it's going to have a different energy level, sublevel, orbital, and then the biggest one is spin. Okay, so for every up arrow that you see, you're always going to have a down arrow. So that's why when you saw me drawing up here, for every up arrow, I drew a down arrow. I should never, never, never see something in an orbital that has 2 arrows going up or 2 arrows going down, because you have to think electrons want to repel realistically, and the only thing that's keeping them together is their opposite spins. Okay, so for every up, I have to have a down. Okay, and so that's what Pauli exclusion principle is telling me. Okay, so this is huge to remember. Okay, so make sure you're writing these down. Hund's rule states an electron will occupy the same energy orbital so that they have as many of the same spin until they run out of orbitals to fill. Then we start having opposite spins. So notice I have an up arrow, up arrow, up arrow. Instead, I didn't do an up arrow, down arrow, up. Okay, it's going to fill every orbital first before it puts in that opposite spin. Okay, so if we actually go back up here to kind of help you see that, I'm going to have an electron fill here with an up spin, okay, or it's counter, let's just say it's counterclockwise. Then I'm going to have an electron fill here, and then I'm going to have an electron fill this orbital. Now that each electron has its own orbital, then will I have electrons start pairing, and they'll have their down spins. So that's what this is saying, okay? And so it's not going to have an up spin and a down spin when an electron's going to want its own orbit, okay, or its own orbital, okay? They only start pairing when they've already filled all of the orbitals, okay? And so just a reminder, these lines are representing those orbitals. Okay, so what I want you to go ahead and do is go ahead and work on your quantum model of the atom. I want you to try to answer every question on your own first. I get it's probably going to be difficult for some of you. That's fine. I'm going to post another video after this, okay, going through the whole worksheet and where I'm finding the information. But please try it on your own first. Tomorrow, I'm going to post another video showing how to do orbital and electron configurations using the off-ball diagram. Or if you cut out and make your own periodic table, the periodic table, I'm going to show you how to use that as well. Okay, so go ahead, make sure you have these notes written. Go ahead and try your homework for Thursday, which is the quantum model of the atom. Okay, and then if you have trouble, watch the quantum model of the atom video.